So I want to talk about the aware organization, and you see the subtitle here is Jidoka. So why do I say that? You've seen this picture before, so I won't go over it. And I propose that what I've heard today is we've gotten pretty good at knowing what flow means, and even what one-piece flow means in the software development and delivery world. And I even heard Ing is doing it in 2 weeks, and lots of places are doing one-piece flow in a day, but not so much what Jidoka means. So not even I, although I did lean in a manufacturing plant, was quite sure how this works in software development until I talked to Nicholas Modig. Nicholas wrote this book along with Per Angstrom, I think his name is, who Nicholas went to Toyota and made himself an apprentice to a sensei there to learn what it was that Toyota was doing. And his first book was written in Swedish because, of course, they're Swedish. And then they rewrote it in English. And that's the one I wrote because not only don't I know French, I also don't know Swedish. And it's a really good book. In Sweden, it's the biggest selling business book that's there. And that's not a software book, it's a business book. In fact, it's not actually about software. Time and I saw Nicholas a few months ago, and he said that the book is all about flow, but he needs to write another one because he missed something. It's just sort of tucked into the end of the book. So when he was in Japan, his sensei from Toyota said, "What makes a winning football team?" So what makes a winning football team? You can be sure that no matter what he said, he was going to be wrong because the sensei asked it, right? So after probably everything that you guessed, he tried to guess, the sensei says, "So what makes a winning football team is the football team is aware of everything that's going on the field. They know where the referees are, they know the score, they know the time, they know what their role is here. They're constantly aware of where the ball is. And their whole job is to move that flow unit," Nicholas talks about flow units, "from down the field and into that net." And the more aware every single person on a team is of what's going on and what their role is, and the more capable they are of then doing that, the better off the team will be. But, he says, if you look at our big corporations, they look more or less like this. The score is, obscured with advertisements, and there's lots of tents, and everybody thinks if they kick the ball out of their tent, we win. And this is not the formula for winning teams. So what you need is overall, across the whole field, across the whole organization, awareness of the flow unit moving through the organization and getting to customers. And according to Nicholas's sensei, that's what makes a winning team, whether it's a football team or an organization. So I was fascinated by this concept of awareness, because awareness of what's going on and where the flow unit is and how to move it was, as he said, the definition of Jidoka. So Jidoka isn't about stopping the line. It's about everybody being aware of what goes wrong and fixing it instantly, which is a sort of a higher level view of Jidoka. And so that's what Nicholas thinks that he learned when he was there, is this awareness is the same thing, but at a higher level. So everybody sees anything that happens, good or bad, does something immediately about it so that the flow unit can keep moving and keep moving constantly. So that reminded me of this interesting book, and it's, I don't know, maybe 15 years old, called Managing the Unexpected. And it's about high reliability organizations. And if you're in healthcare, you might have heard a lot about high reliability organizations and the findings of this book, because the whole idea is that these kinds of organizations work in dangerous environments. They have more than their fair share of unexpected events and less than their fair share of accidents. And being a person who flies on airplanes all the time, I'm really happy that airplanes are right up there at the top, commercial airlines, of high reliability organizations. So this book is by Carl Wake and Kathleen Schutkiff. I wish I could say those names better, but you can see it here. And it'll be on my slides. And what they did was they said, what kinds of organizations are like this, like firefighters or nuclear power plants or power grid dispatches, air traffic control, commercial airlines. In fact, you know, down here in motorcycle riding is the sort of least reliable thing. And as you get up there, there's chemical plants. And way up at the very safety, very carefully safe organizations would be in the commercial airline area. So the question is, what makes these organizations highly reliable? And their answer was this one word, mindfulness, which reminds me of the Toyota focus on awareness, same concept. What makes people, all people in the organization, mindful of their job, of what their company is trying to accomplish, and how to accomplish it well and safely? So in the book, there are 5 conclusions. There's a preoccupation with failure. There's a reluctance to simplify, being very sensitive to operations. In fact, highly reliable organizations have excellent operations. You miss this, and you're not going to be reliable. A commitment to resilience. So failure is not about punishing people. It's about finding out the cause. And a deference to expertise. That is, decisions are made by the people with the proper and most correct knowledge of how to make the right decision. And mindfulness leads to exceptionally safe, reliable, world-class organizations. So if we look at this concept of mindfulness, or let's go back to the word awareness, there is an organization, or set of organizations that have been around the world for a good long time, to which this word is also a very common word. And that would be military organizations. So we've been hearing a lot about scaling and getting big and how do you make stuff happen across larger organizations. And we've seen all kinds of models, but a good friend of mine, Robert Benefeld from London, who does a lot of stuff in ops in very large organizations in the software environment, says, you know, the only thing that actually really works is the military model. In the end, the military model is about small teams, you know, 7 to 9 people, which is a squad. They live together, they get orders together, they learn how to be very good friends with each other. And then they're formed in groups of, maybe 30 or 40, maybe 3. That would be something in this rifle group like a platoon. And then you may have a company above that. And what happens is the first thing that the squads and platoons know is what is the command intent? 2 levels up. Not at the platoon level, but higher up than that. The next 2 levels up, what is a concise way of talking about what we're trying to accomplish? And what's the desired end state look like? So it's not, here's something to do. It's, here is the intent. Here's what we're trying to accomplish. And here's what perfect looks like. And secondly, you maintain situational awareness 1 level up, so at the platoon level. You keep track of what the other squads are doing. You know together with them who's supposed to accomplish what. You watch to see whether or not your fellow folks in that next platoon over there, or the next squad over there, are actually accomplishing their thing, and you help them out if they need it. Because, you know, if this is a matter of life and death, you don't want to say, I've done my job, I don't care about the rest of the folks, because that could be a little bit dangerous. You want everybody to accomplish the objective, not just my squad. So situational awareness of what the other platoons are doing, because you help plan together, and then adapt to make sure that the company reaches the desired end state. So you have this concept of keeping track, not just of what I'm doing, not just what my team is doing, but what are we trying to achieve at the top level? And how are we going to work together to make that happen? And how are the other squads coming along? Because I might need to help them out to make sure that the desired high-level goal is met. So that's another way of thinking about mindfulness or situational awareness or awareness. People need to be aware not just of what I'm supposed to do, not just what my team's supposed to do, but what are we trying to accomplish at the couple levels up from my pay grade, right? So if I think about it that way, then Jidoka is mindfulness or situational awareness, being aware of how things are unfolding, how the flow unit is moving through the organization, how my fellow teams are coming along with their part, what kind of help they may need, so that everybody is focused on getting that flow unit through the organization. So let's go back to this mindfulness thing again and talk about some of these things that a mindful organization does. I'll start with the preoccupation with failure. Preoccupation with failure, of course, if you're flying an airplane and there's been a crash, you surely want everybody to find out exactly what happened to make sure that that doesn't happen again. And the commercial airline industry is incredibly good at that. There was a story of one near crash at Heathrow. It was attributed to a frozen fuel line from flying over the pole. They decided it was a probable cause, created a new checklist, got it into the airline checklist books on the airplanes in about 2 weeks from the decision. And about 2 weeks after that, an airplane flying into Atlanta had exactly the same problem. And the checklist on that plane gave the pilots instant information on don't pull back, but gun it, and you'll probably break the fuel block, and they did. It's that fast that the airline industry is able to take accidents and put the learnings in every other plane. So that concept of preoccupation with failure. So how does that work in a software world? Well, the theory of constraints tells us something. It tells us that the problems we should be paying attention to, because we have tons of them, are the most important problems that block flow. So every system has a bottleneck. And if you want your system to improve, what you should do is take all those teams that are out there doing stuff and make sure they focus on the bottleneck. Because if you dig this ditch deeper, that's not going to make water come through that pipe any faster. So if the bottleneck is the pipe, then all of the teams really need to focus on the pipe before you worry about digging the ditch deeper. So you don't want teams scattered all over doing whatever. You want to say, what kind of goal can we give to the team so that they will focus on the most important things? So if that's the concept, what are the two big bottlenecks that people run into again and again and again in software development and delivery? Well, I propose two. One is technical. So this is a pretty classic constraint, and that has everything to do with the integration problem. So you have a release cycle, and at the end of your release cycle, you spend what? I don't know, 2 months or more hardening your code. Does that sound familiar? To most people, not the young folks that were just up here. They only did that 2 years ago, or 3 years ago, but they fixed that. But typically, we have seen 30% of any release cycle spent in hardening the code. So you spend 2/3 of the cycle putting in defects and 1/3 of it removing those defects. Pure waste. That's waste. That's the biggest waste if you have it in your whole development process. And that's where to focus your teams. Number one, if you have this typical 30% of your development cycle on hardening, you got to figure out, why do I need to harden it? Why do I even think about hardening at the end? Why can't I create an environment where when I, as a developer, do something, I know that it's right? I know that nobody's going to tap me on the shoulder a month later, 3 months later, half a year later, and say, you know that code you wrote way back when? Well, it's wrong. Well, I don't care. I mean, I'm sorry. Why don't you tell me now when I'm writing it? Now, why do you tell me so much later? We've seen this 50% or more. Top companies used to get to 10%. That was back in the days when there were still iterations. Today, with continuous delivery, there isn't a hardening phase. You push a button and it deploys. And those of you that weren't in this room the last hour, that's what Ing does. Go in from 2 months to 2 hours. and they're a bank, okay? Even banks can do this. Enterprises can do this. In fact, continuous delivery was designed by well, he sort of wrote the book on technically how do you make this happen, mostly for enterprises, not for internet companies. Internet companies sort of have been doing this, but in fact, enterprise systems, you really want to do this, because if you have this big 2-month chunk here, that means you spent 4 months there. What you're doing is every 6 months, you're smashing your very complex code base with a great big punch. If you deploy every day, you're poking it, and then just a little piece of it, and then you react. If you want code stability in a complex environment, you got to stop smashing it and start poking it a lot and figure out how to respond rather than smash it with great big changes all the time. And you've got to get into your head that not only is this waste, but it leads to strong instability problems across any company that thinks this is a good idea. So that's when the constraint is technical. And when the constraint is knowing what to build, that's our other really big waste in software development. In fact, probably the biggest. Building unnecessary stuff that people don't use. Maybe 2/3 of custom systems. Maybe that was true when the study was done in 2000. Maybe it's still true. Don't need to be there. That code never needed to be developed. And maybe only 20% of what's sitting in a code base actually needed to be there. And this could be just about any code base, but especially custom built stuff, especially IT systems. I told this to a company in Edinburgh. It was an insurance company, right, Tom? Pensions, yes. And the CIO said to himself, what dumb management team would allow something like this to happen? But Tom and I had just done a workshop with their top development team, and I said, you know, actually, your guys think it's about 70% in your company. And that shook him up so bad that he kind of wholly rethought the idea of why do we have our developers so far divorced from our insurance folks. So the cost of this extra stuff in a complex environment just goes up, you know, hyperbolically. Every single bit of code that doesn't need to be there that's there is got to be built and tested, and it messes things up. You know, code is bad. You never, ever, ever measure software productivity by how much code there is. The more code, the worse. The more features, the worse. The more functions, the worse. All you're doing is adding complexity. If what you add doesn't really, truly add value, then you're adding stuff that's bad, not good. So that's preoccupation with failure. And I say we should be very preoccupied with, first and foremost, those two failures in software, if you want a lean concept. So let's talk about reluctance to simplify. So, and I asked the guys at Ingram, who's responsible for delivering value? So if you take a look at who's responsible for delivering value, in delivery organizations, which I think of IT as delivery organizations, typically there's maybe the business or the product owner or the contracting party or the outsourcing company or, you know, whoever. Not my job. Somebody tells me what to do and I execute, no problem. In product organizations, it pretty much doesn't go that way. It's pretty much, this is a shared responsibility across everybody involved in putting software on the market. Because in product organizations where you have product managers, typically a product manager decides what the market wants, and they're not right all the time. In fact, if you do the research, you find they're wrong about 50% of the time. So you could flip a coin, actually, and be about as accurate as a product manager. So honest, and that's Microsoft research, really. And so the thing is, you need to help those product managers know whether or not their cool new idea is actually a great idea. So you need to make sure that delivering value is a shared responsibility. So you want to make sure that you have, with shared responsibility, rich objectives across not just a development team, but across everybody that's going to deliver value. You need a unifying goal. Okay, we are going to make this customer feature so good that we take away 10% of our competitive, our competition's market, whatever it is that you are trying to do. It's that kind of goal you communicate to all of the various people needed to do it. And what is our team going to do for that? And how are we going to make sure that the other teams are successful? Because we succeed or we fail together as a group. So this concept of shared responsibility means you can't simplify by saying every single team is going to have its own narrow objective and focus. Any more than you can say in a lean organization, every single department is going to have its own narrow objective or focus, because that doesn't ever lead to overall flow and overall optimization of the whole company. So moving on with that, let's look at this one, deference to expertise. This guy, Tom Guild, started writing about incremental delivery in about 1983. He wrote this book in 1988, which is Software Engineering Management, which has gone through 20 printings and very popular. And he was quite pleased to see the Agile community and world come along because, yeah, now some people are finally listening to me on this incremental delivery thing. And he became quite disillusioned because he realized that one of the key concepts that he's been trying to promote is pretty much absent from Agile, because Agile focuses only on software development as if it were the key bottleneck instead of on figuring out what to build. And so he proposes, and has, by the way, for a long time, that you control projects or any kind of development effort by a few quantified critical business results, not technical results. No pages of specs, but what numbers are we trying to move from a business perspective? So you don't have your businesses tell you what to do. You have your businesses make it clear what kinds of metrics they're trying to improve on. And you give developers or your technical team the challenge to solve those problems, to move those numbers. We just heard from Ing that giving development teams, technical teams, challenges to solve problems is an amazingly effective approach. And the concept here is exactly the same, but let's not just give them process problems to solve. Let's give them real business problems to solve. We would like to go this direction. We would like to make this thing happen in the marketplace. And when you give them those kinds of high-level goals and objectives, then they're much more likely to actually deliver against those objectives. And then he proposes that you estimate the impact of the designs that the engineers and the designers come up with against the goals, the measurable impact they're likely to have, and you select the ones that are going to have the biggest impact, and you decompose the workflow into small chunks, typically a couple of weeks. And then you actually have people that are going to be affected by the various stakeholders see the deployed code in real life and the metrics that it changes one way or the other, and determine, was that a good idea or was that not a good idea? And change the designs and maybe even the high-level objectives based on visible results of deployed code. And so this is sort of his 10, here's how you really ought to do these things you guys call projects or maybe even product development efforts. So it's not about somebody telling a very competent development team what to do. If they're the experts in helping to solve the problem, let's let them do it. Let's quit telling teams exactly how to solve problems. Let's let them solve problems. When I was developing code, I was a process control engineer. I developed big process control systems with other engineers, electrical, mechanical engineers, and we did the control piece. And I don't ever remember requirements, stories, nothing like that. All I remember is we had about a year, and we had a few quote-unquote requirements. Had to be done on time. Because If it wasn't, it was very expensive. It had to make good product. You know, this control system had to make good 3M tape or whatever it was supposed to make. It had to be something the operators would find convenient to use, because otherwise they wouldn't use it. It had to be something the plant engineer could maintain, and so you had to think about that when you thought about the technologies in use. It had to be made out of the latest technology. Did I get them all? I think that's it. Those were my requirements. And against those requirements, we spent a year putting together a process control system, which we delivered into the plant about 2 months before and spent maybe 6 weeks starting up, and it always worked. We didn't have these things called disasters. That stuff just plain worked. And it was easily as complex as many of the systems that I've seen, but we had lots of senior engineers around who've been doing process control systems who could give guidance. And we had high-level objectives against which we did best efforts. And as an engineering team, we tackled and solved the problems. And we need to do that more with our smart software engineers, too. Sensitivity to operations. So let's get to this whole thing about what's going on in operations today and how we tie development and ops together, which I think there's been some talks on. So I won't say a whole lot about it, but today, this is no longer a mystery or an unsolved problem. It is very technically possible to be delivering software very securely in small chunks all of the time. Yeah, you need a lot of automation. Yeah, you need investment in test frameworks. Yes, it's technically difficult. This doesn't happen overnight or in a week. Every company, and I'd say, what do you say, now half to 2/3 of all of the companies we run into in our workshops are either there or close. And they always tell me, if I say, what did it take? They say, about a year. They don't say money, they don't say management approval, they don't say it was, you know, we needed this tool. They say about a year. Once the organization has decided they want to go this way, it takes about a year. But in this world, acceptance test-driven development means that you write the specs as tests. The specs are tests. And in fact, because the specs are tests and automated tests, so you have automated tests, you actually can't write defects. Because you know right away if you're not meeting spec. You can have bad specs, but if your specs are, whatever your specs say is what the code does. You have tight collaboration between business and delivery teams. So, you know, on the ops side, it's great, but the fact is, if you're delivering all the time, frequently into production, you got to know what to deliver, or you could deliver a lot of junk. So you also need to couple real tightly back up with the top end of how to decide what to do. And your cross-functional teams have to include QA and ops and product people, or people who understand what it is you're supposed to do. And you have automated build. Everything's automated, so you push a button and stuff happens. You have, for those of you that know what a branch is, how many know what a branch is in software, okay? Well, you develop to the trunk. No branches, which shocks people at first. And then you turn off the code that you're not quite ready to expose. You turn it off with a switch. But your code is deployed into production every few hours or every day. And then when you want to actually release it, you just turn on the switch. So you totally decouple deployment from release. Deployment is continuous. You develop to the trunk, you deploy every day, and then you release when the business situation says it's a good time to release. And software is always production ready, and releases are tied to business needs, not operational constraints. So this is software engineering today. This is excellent operations. You actually need to head this way if you want to think about having top-notch operations. And this is fundamentally a set of technical problems that are challenging, but it's been done in embedded software. It's been done in virtually every kind of enterprise I know of. And certainly, those guys on the web have been doing this in their sleep for quite a few years. And then the next one is commitment to resilience, to recovery. Okay? But I would like to call this a little different. Let's call it commitment to learning. And in this environment, I want to give you a couple of examples of commitment to learning, how this works. And I'm going to start with the UK government of all places, because you know, all governments, our government in the US included, has these massive projects that fail and whole bunches of money go down the drain. You've heard of this. So in the UK, and we had our disaster last year. No, we've had one of our many disasters last October, but this one is the British National Health Service, where they spent from 2002 to 2011, maybe 10 billion pounds that were wasted in trying to get electronic patient records. And so we only wasted maybe 10% of that on our healthcare.gov disaster. But anyway, if you think about it, these kinds of disasters do not need to happen. So one of the senior, actually conservative people in the parliament, what do you call him? Anyway, one of those guys, he visited Estonia. Well, Estonia is the most automated country when it comes to especially government that I have ever run into. And they did this when they started up their government in the late 90s because they didn't have a lot of money. And so they didn't have money to build buildings and have people sort through paperwork and long lines. And so they decided, we're just going to put everything automatic. So in Estonia, it doesn't matter if you want a marriage license or license your car or get some medical care or get your kids' school grades. You name it, you do it with your USB chip or your mobile phone, which has a very secure identity code. And then you go online and poof, it all happens. And because that identity code works so well, it became available to banks and transit companies. So you use your card to get on the bus and pay for it. You use your card for all your banking transactions. And it turns out, yes, it's a whole lot cheaper. So the guy from UK went to Estonia and said, yeah, we need this in UK because we actually are kind of running out of money here. You wonder why. And so they started a whole new area. First of all, they have people in the UK government, not outsourced, partly because the laws say that if you outsource, if you outsource, you actually have to go through all these, rules that you don't have to do if you have people there. And what they do is they have a process which has a team. The team is led by a designer and really good technical folks, and they get a project, a small project. They get 4 to 8 weeks to really understand what the problem is and understand this little piece of government and how it might be properly exposed electronically to business, whether it's figuring out how to file taxes or you name it, some small piece of the UK government they're going to make electronic. And after about a month or two, they, with a good designer up front, to have a really nice design, because with its user interaction, if you have no design, if you just leave design to chance, it's not going to work anyway. Forget the rest. And then they do some trials, take 6 to 8 weeks to do some trials. And then they gradually release it, 20% of the customers, and so up to 100% over maybe a couple of months until they get this electronic service working well, get all the kinks out of it, get great feedback, and then they go live, and then they do it again. And they've been doing this for a few years, and they are gradually making all of the various transactions in the UK government electronic through this process, which probably is going to cost a whole lot less than 10 billion pounds, and probably is actually going to work. In fact, has worked so far pretty well. They've actually won design awards for their website design because they start with design. So their general principles, as for people managing these teams, is don't slow down delivery. Decisions should be made when they're needed and where they're needed and at the right level. Do it with the right people. Go see for yourself. If you want to know how projects are coming along, go into the team room and look at their charts, for heaven's sake. Don't expect status reports. Only do it if it adds value. Trust and verify. And a delivery team gets a quantifiable goal. We want, in 2 months, 20% of this kind of transaction to be done online once we go live, or those kinds of numbers. And they have to have a service vision. They have quantifiable goals of targets that the team is trying to figure out how to reach. And that's it. And then their key performance indicators show how well they're meeting those targets. And that pretty much is what the teams get. Beyond that, the teams figure out for themselves with the right folks on the team. Small team, but with good design and good technical leadership. So I like to talk about this concept of impact-driven development. The idea here is you work backwards from knowing the kind of impact you're trying to have. You start with why. Simon Sinek has a wonderful TED Talk about starting with why, because people are inspired by knowing why they're doing something. So you might want to look at that. You start with making sure the team understands why they're doing something. And then you look at the Tom Gilbert and his son Kai, they say you have to then understand what's the impact on all those various stakeholders, because there's not just one. There are multiple stakeholders who are going to care and who are going to measure your success on some metric that they have in their head. Figure out what those metrics are and figure out how you can move those metrics. And then try your design changes, because half of them will fail. And if they fail, that's okay. You've learned, and kick those ones out. And only do the ones that are validated against real users as actually doing what they're supposed to do. So you want to deploy, you want to measure the result, you want the team to know whether or not what they've decided to do actually changes the desired business metric. It's not something that comes in later. They deploy and they measure, and then they react to the measurement. And so you do the experiments. This is a pretty classic lean startup concept. You implement changes only if they are desired, and then you iterate rapidly until the desired impact is achieved. So that's the concept of knowing what to do and making sure that people use a learning process to know what to do. At a how am I going to deliver value level? I thought you were going to ask me the biggest problem IT organizations have, besides those two I mentioned before, the big deployment problem and the knowing what to do. It's being too far from value. Not knowing exactly what real business value is going to be delivered by what I'm doing. And we need to tie teams to understanding the value and then challenge them to figure out how to deliver that value, not tell them how to deliver the value. So just to prove that this is all possible, I want to talk about last week when Tom and I were in Australia. We were in Cape Town at this point, and we had South Africa. Thank you, Tom. That's why he's here. Keep me honest. We were in South Africa. We were actually in Cape Town, and we had a workshop with 5 teams from 5 different companies. And what we were doing in this workshop was having each company draw a value stream map of typically what happened in their company. And then then we talked about them. Each one presented, and we critiqued, and we had plenty to critique. We often do this, and it's really an enjoyable thing. It's not any real formal value stream map. We never allow them more than like a half an hour to put one together. And it has to go end to end, customer problem to customer solution. And about the 4th time, the 4th value stream map, we got this crew from Durban, and they're doing mortgage securitizations, what their company does. They have maybe, 70 or 80 developers. And maybe 2010, when the book Continuous Delivery, Jez's book, came out, they started changing the way they develop software. And I'm not quite sure why they were in the workshop, because at that point they taught the class for about a half an hour, because they were doing continuous delivery into production every single day with teams that they had consciously structured so that each team had a couple of legacy guys, a couple of new age guys, so that there wasn't trouble between the 2 different kinds of software, front end and back end. Ops folks, and every single day they were deploying live into production. And so everybody else in the room, all other either banks or insurance companies, asked him question after question after question. How did you do that? And how does it work? And how did you do this thing? And how did you do that thing? And the one that sticks out in my mind the most is they said, what about defects? And they said, well, we don't have defects. We don't have defects because we have all of our tests in a language that people can understand, but also test the code. So there could be a problem with the spec, but there isn't a problem with the code. And that shook a few guys up. And then because I've seen a lot of this, and Durban isn't the biggest city in the world. So I said, I'll bet your developers would never want to go back to the old way. And they said, oh no, never want to go back to the old way. And I said, and I'll bet in Durban you're the only game in town that's doing this. And they said, yep. And I said, I'll bet you don't have any retention problem. And they said, as a matter of fact, we've had 0 turnover in the last 3 years except to immigration. The developers love this environment because they can know instantly why they're doing something, what they're doing, see its impact, get feedback, and don't have people tapping them on the shoulders way downstream to fix problems they should have known about immediately. So we have to create an environment that has these kinds of tools available because they exist, because your competitors are going to get there. So if you don't, then you're going to have to deal with companies that can, even in banking, even in insurance. So I propose, if you think about it, for banking, early 2000s, telecoms had lots of money. And then Skype and voice over IT came, and they took something like $3 trillion a year of revenue, long-distance phone call revenue, out of the telecom industry. And that's why we have company after company just plain disappearing with only a few survivors, because there's no money there anymore, because there was something that really didn't cost very much for which there were no other options and they were charging a lot. So now I suggest you go home and say to yourself, what are we doing that really doesn't cost very much, for which we charge a ton of money, and who's going to take that business away from us? And how many years do we have before it happens? Because it's coming. If you're doing something that can be done a lot cheaper, somebody's going to figure out a way around that. And that money is going to disappear.